Hello, students. Good morning. It's a lovely Wednesday, right? I hope you're having a good time. I hope you have lessons. Okay. Good morning and welcome to my class. Okay. For those who are not my students, it's all right. Okay. I welcome you to my class. So today I'm going to continue with electricity chapter on chapter 6. Okay. So I would like to know whether you are here. I can see some comments over here. Okay, girls, I was actually waiting for 1 minute so that you're able to come in, join my class from your previous class. So I didn't start on the dot. I waited for 1 more extra minute. Okay, so nice to see all of you here. Okay, Stella, Crystal, Cosin, Hui En, everyone, good morning. Okay, Vivian. Okay, Hui Hui, Chai Xuan. Okay, Zing, Winnie, Eileen, Janice, and so on. Okay, good morning, everyone. Can you hear me? Am I coming across loud and clear? Okay, can. All right, okay. So I think I will share screen. All right, now I hope you can see this. All right, I'm looking at it. I think it's all right. All right, okay, Stella, thanks for the feedback. Okay, you're able to hear me. Okay, now today I'm going to talk about and also the distribution system of electricity. Okay, in the previous lesson, what you learned was transformer, the function of transformer, and after that, you also learn how to calculate the voltage and the number of turns and so on. So in today's system, we're going to learn about, in today's lesson, we're going to learn how this electricity that comes from Tenaga National Berhad, okay, it comes from the power station, is transmitted to our houses for us to use. How does it come from, so far away? Now you have Empangan, Kenyir, you have Bakun, you have other power stations all over Malaysia. How do they get to our houses? How is it transported to our houses? Okay, how does this electricity come to our houses for us to use as a consumer? Okay, so this is according to the textbook, right? This picture is to the textbook. Then you will see that, now, first of all, we have transmission. Transmission is, it's like, you're bringing, spreading. Transmitting means you're transporting it, okay? Transmission, 传动. This is called transmission. Distribution is almost the same meaning. It's just that you're distributing, you're giving it to other people to use. Okay? So 传动 and 分发. This is the meaning of transmission and distribution of electricity. Okay, first of all, let's look at where the electricity comes from. Okay, if you look at our previous lesson, you will know that all our electricity comes from the power station. Okay, in Malaysia, we normally use hydroelectric power station, hydroelectric power station at the Empangan or the dams. We also have other types of power station, the thermal power station, okay, where we burn coal and all that, right? So here, now at the power station, this is the source of the electrical energy. All the electrical energies that we use now in our homes, it comes from the power station. So the generators, okay, you learned that in the previous weeks, how to produce electricity. You need generators. So the generator with the iron, iron core with a lot of these wires, okay, copper wire, and you have this very strong magnetic field. So when it turns, right, it cuts the magnetic field lines. You're going to get induced electricity, or we call it induced current. So this is your AC. So at the generators in power station, the type of current that they produce is AC, alternating current. Okay, so in our country, we produce electricity. The type of electricity is called alternating current. But you see, the alternating current here, the voltage is actually quite high. Okay, it is produced at a voltage of 11 kilovolts or 25 kilovolts, depending on what type of power station. Now the kilo here actually stands for 1,000. So if 11 kilovolts, it doesn't mean 11 volts. 11 kilovolts means it's 11,000 volts. Okay, 11 kV actually stands for 11 kilovolts. So it's actually very, very high voltage. Quite high lah, I would say. 25 kV is actually 25,000 volts. So this is the voltage that is produced at this power station. Okay, it's either 11 kilovolts or 25 kilovolts. Now, so you need to transmit this current to everybody to use all over Malaysia. Correct? Okay, so you have to send it off. Now, how do you send it off? You need this kind of transmission. See all this? You transmit through long distances. You have these very long wires. You will see along the highway, as you go along the highway from Ipoh to KL or maybe Ipoh to Penang and all that, you will see along the highways you have all these transmission cables. Okay, your transmission cables, it runs all across the nation, all across Malaysia. Okay, so you have this wire and they're carrying very high voltage. Now, this system of wires going all over Malaysia, this is called the National Grid Network. National Grid Network. Okay, wait. Now, National Grid Network. So it's transmitted through all these high voltage cables. All right, now, this high voltage cables, this structure is called pylon. You see these structures? These very tall structures that carry these cables. That structure is called pylon, but the system is called National Grid Network. Okay, so these pylons, they put it so high up so that nobody can touch it. Okay, because the cable is very carrying high voltage. Right, so you see it transmits all this electricity at high voltages all over the country. It goes to the, of course, come to Ipoh, right? It also goes to KL. It goes to Penang. It goes to everywhere. Every city will have this electricity transmitted to the country, to the city. Okay, now, just now we said the voltage that is produced, the current is produced at this 11 kilovolts or 25 kilovolts. Now, so if we transmit this electricity at 11 kilovolts or 25 kilovolts, what happens is this current is carrying energy in the form of electricity. So when it's transported along a long distance, okay, there will be heat generated. Okay, the wires will become, this energy in the form of electrical energy is not 100% electrical. It could be turned into heat. It could be turned to something else. So when you transport it along long distances, some of the energy will be produced as heat. And as you know, heat will dissipate, it will spread out, it will be released. So when it comes to where you want to have the electricity, some of the energy is already lost because some of the energy is already turned into heat. Okay, the heat is your energy loss. So therefore, you see, that means that whenever you produce any electrical energy or any energy, when it's transported over long distances, it is not 100% only electrical. It may be produced into heat. So as heat, the heat will be released as it goes on, the wire becomes hot and so on. So when you arrive at that place, you will have less because some of the heat is already lost. So the energy that arrives at where you want it to arrive, it will be less than the original. It will not be 100%. Okay, so you may even get less. Okay, if you start off with something that is so little, let's say 11 kilovolts, you may even get even less than 11 kilovolts. So in order to prevent that or to minimize the energy loss, what they do is they increase the voltage first. Before they transmit, they increase the voltage. So that's why you see the voltage here is when you want to transmit this current or this electricity, they do not want to transmit it at 11 kilovolts or 25 kilovolts. Because if it's already started at this amount, when it reaches that place, it will even be less. Maybe even less than that. So we want to increase the voltage first before you transmit that current or the electricity. Okay, so what they do is they increase it to even up to 132 kilovolts or 275 kilovolts or even 500,000. Kilo means 1,000, it's 500,000 volts, that is very high. So we need to increase it. So as you know, how do we increase it? From 11 kilovolts, how do we change it to 132 kilovolts? We need something to change it, right? We need a device to change the voltage. Remember, if you tie back to what we learned in last week, our lesson on transformer. Transformer can change the voltage. Okay, so you have 25 kilovolts, okay, and we want to increase it to, let's say, 500 kilovolts or 275 kilovolts. So you need to increase the voltage. And what do we need to increase the voltage with? We use what to increase the voltage? We use a transformer. Okay, but what kind of transformer? Okay, maybe you can put in the comment there, what kind of transformer we need to increase the voltage from 11 kilovolts to 275 kilovolts. What kind of transformer do we need? Okay, maybe I'll wait for your answer. Okay. Then after that, now come to here. Now your voltage is already increased. Let's say now it becomes 275 kilovolts. So these cables that you see here, it could be 500 kilovolts, or it could be 132 kilovolts, or it could be 275 kilovolts. So it's actually increased to 75 kilos. Okay, so this is the amount, this is how high the voltage is whenever you see all these cables along the highway and all that. Okay, so let me see whether you have any answer for that. Step up, yes, very good, step up transformer. So you will see here, that's why we need a step up transformer at here. This is a step up transformer. So we have a station there. Okay, so this cable or this electricity, before you transmit it out, you have to step it up first. So you can be step up to 132 kilovolts, that means 132,000 kilovolts, or 275,000 kilovolts, or even 500,000 kilovolts. Okay, using a step up transformer. So this is a step up. Okay, step up transformer. So that is the function why we need, or why we need so many types of transformer. Okay, so it's step up to increase the voltage. Okay, so now this whole thing from the power station, okay, PS here stands for power station, until you reach here, your national grid network. Okay, here, this one, right? The whole system here, right? From the power station to the national grid network, we call this the transmission system. So this is the transmission system. And for transmission system, usually we step up, right? We step up the voltage. Now let's say these cables are already, all this electricity running in the cables, right? Current cables. Now let's talk about Ipoh, right? Okay, we come to our city, come to Ipoh here. So we come to Ipoh here. The first thing is it goes to a main station, main station. Okay, it comes to a station. I'm sure you have seen along your, I don't know where, maybe Lahat or Jelapang, you have this kind of station. You see main substation, right? At the roadside here, one big building, TNB, right? And then we'll sign it higher, right? All these things. This is a main substation. At every city, you have a main substation. What happens is at the main substation is they will convert that electricity, which is at high voltage, 275 kilovolts, all right? They have to change it, step it down, or change it or convert it into lower voltage. Okay, now at this place also you may have a switch zone. A switch zone is to control how the electricity is channeled to where you want to channel this. You want to bring this electricity to which place. Let's say this one go to Bacham, this one go to Manglembu, this one go to Lahat, all right? This one go to Ipoh Garden. So you have to, switch zone is to control, right? And also to channel it. And also whenever you want to do any repair work, you need a switch to close the circuit, right? So you need to control. So the switch is to control the supply of electricity and so on. And also you need to determine where you need to send the current to. Okay, so you have a switch station here. You also have the main substation. So now the main substation here is 275, right? Here's the current that comes there. I mean the voltage is 275. So you may need to step it down because you don't need that 275 kilovolts. It's too high. So for we call it factories. So the factories, we look at the Kawasan Perindustrian. Okay, you have Kawasan Perindustrian Silibin, you have the Kawasan Perindustrian Jelapang or Manglembu. Now they have a lot of factories there. So these factories, they have this very high power motors and machinery. So this machinery needs a lot of electricity. They need a lot of power, right? So this electricity now is channeled to this heavy industrial area, but because they need higher, their needs, because of the motor runs on higher power and so on. So this current is stepped down to 33 kilovolts. Okay, so this heavy industrial area, the electricity, the voltage of it can be up to 33,000 kilovolts, 33,000 volts. Okay, if you say kilo, you don't need to say thousand. It's either 33 kilovolts or 33,000 volts. Okay, so this is a heavy industrial area. This is perusahaan berat lah, big, this what you call the factories that really produces a lot of this, like let's say a car factory and so on. Okay, heavy machinery. Then there are also other smaller industries or factories. So we call it a light industrial area. These are the places with smaller factories. So probably they do not need that much, maybe only 11 kilovolts. So you have another transformer to change it from 33 kilovolts, okay, is converted to 11 kilovolts. And what do you need to use to convert this voltage? Okay, just now it was 275. 275, you change to 33. What do you need to change this? And then from 33, now you change it to 11. What is the component? What is the kind of thing that you need to use to change the voltage? Can you write in the chat box? I'll come back to you later. So you see, this is, you have one main substation, right? In the city, you have a one main substation. Then after that, you have other smaller station called the branch. Branch 分行, that means the smaller ones. Okay, labeled as E1. E1 is one branch. The E2 is another branch. Okay, so at every substation, whether it's a main substation or a substation, a small branch substation, you have something to change the voltage. What do you call this thing? Okay, to change the voltage. Usually, it is to decrease the voltage. You call it a, yes, good, step-down transformer. All right, good. Thanks for your answer. So this is a step-down transformer. When you want to use it, you have to step down the voltage. So here is, you need a step-down transformer. Step-down transformer. Okay. This is, well, not this consumer. Consumer people will use it. Okay, just now you're just transmitting. Now you're coming to a city and everybody using the electric current. So now, this is for factories. But certain users, you don't have factories and so on, but you have a big building. Let's say, for example, a hospital. All right, hospital, or maybe a big school or an institution or the building, okay, or the town hall. So you have all these big buildings, which inside there, maybe shopping mall also, you have many air cons. You have a lot of usage for all this electricity. So this voltage, 33 voltage, you have to step down, okay, to 405. This is for the users of hospitals, offices, big buildings, shopping mall, and all that. So the voltage they use is 415. So it's no longer 1,000. This here is 33,000. Okay, before that, okay, the light industrial areas, they use 11. Then now from here it steps down further, you have another substation. This is a E2. This is a branch substation. You also need a step down transformer. Okay, so big buildings, a lot of heavy usage of electricity, air cons, okay, many air cons in the whole building, okay, motors, machines, whatever that in the hospital. So they use 450. Okay, now then next one, we have our, of course, houses, right? Our houses, we don't need that much use of electricity. We don't need so much high power and all that. So they have another substation here. Usually at every kawasan perumahan, okay, every kawasan perumahan, you will have another, we call it a substation. Yeah, okay, step down is to decrease the voltage of the current, correct? So now when we're using, you need to decrease everything first. So this is another branch substation. At every kawasan perumahan, you were able to see that. There's one Tenaga Nasional, whatever, a signboard there that says that the voltage, but high voltage, okay? This is a branch substation at any kawasan perumahan. So, and they will convert this, whatever, you know, the wire, the cables at the transmission system, they convert back to 240, and that enters your house. So this is, let's say, your house, okay? You are not using a lot of machinery, not like the hospitals or the offices. So the normal residential areas or houses, we will give you 240 volts. Okay, so you will see that here, the overall picture here, when the electricity or the power supply comes to a city, okay? So we're talking about here, this whole area. This whole area. Yeah, this whole area. This is distribution. Okay, so this is distribution. Distribution of the power. Up here is transmission. Transmission is from the power station, power station up to the national grid network. So this whole thing is transmission. A different color, I can't see already. Yeah. Okay, this whole thing is transmission. Okay, this whole thing is transmission. And at the bottom row here, when you look at it, comes to a city, Everything is step down. So transmission, you need a step-up transformer. For distribution here, you need a step-down transformer all the way. Okay, until you get your 240 volts for your consumption in your house. Okay, now, so you see the words here. You have a main substation, okay, E1. After that, you have many other smaller stations called the branch 分行, okay, or the branch substation. And you also have a switch zone here. Okay, then next one, you have other branch substations, a branch substation. This is to further step down the voltage. You need many others. So for example, in heavy industrial area, you step it down to 33 kilovolts. Light industrial area at 11 kilovolts. And then for offices, buildings, and also offices building, no, I think it's 415. Yeah, right here. Offices, businesses, shopping mall, 415. And for home usage, it's 240. Okay, this is for the houses, residential areas. Okay, so this is what I want to find and let you know. Okay, and some more, this is a little bit more. Now, this is a pylon, right, carrying high voltage current, right? High voltage alternating current on the cables. So when the electricity is flowing through these cables, there will be a strong magnetic field generated. Okay, because of induction of the current. Induction we learned earlier in the Michael Faraday. So he mentioned that when you have electromagnetic field, when you have current, you will have electromagnetic field, and then vice versa. When you cut the magnetic field lines, you get your current. So this one, there is high voltage there, and there is a strong electromagnetic field. So some people, when they want to choose and they buy houses, they will try to avoid these areas because some people do not like all this electromagnetic wave. Okay, because some people are quite sensitive. They find that, some people, when they can't even have the TV in their bedroom. They can't have a TV because they feel that it's interfering with the brain waves, because our brain also is got waves. So they find that, I cannot have it in the bedroom because when you switch on the TV, right, you have your interference from your magnetic waves, your radio waves, and comes into your brain and it disturbs you and you cannot sleep. So that's why they do not want a TV in the bedroom. But some people do not feel that. They're not so sensitive. Okay, so some people do not want to buy houses here because they feel that they have a strong electromagnetic field that is produced from this area, and it will interfere with maybe their health and so on. Okay, so there will be interference. But depends on how sensitive you are. Some people, they do not feel anything at all. Okay, so that is a strong magnetic field. And then if you put a compass within the range or within the field of this electromagnetic influence, you find that the magnet, this is the compass which always shows the direction to north. The needle shows north. Okay, but if we bring a compass into an area with a strong magnetic field, the needle will move. It will not turn. It will not show north anymore because it is under the influence of the magnetic field. Okay, so it interferes with the natural magnetic field of the Earth. So it doesn't show, the compass does not show north anymore. It is under the influence of this magnetic field, a strong magnetic field. Okay, so this is what happens. What is the effect of strong magnetic field to the compass? The needle may not be showing the true magnetic north. It's showing something else. All right, it's showing because it's showing the other direction because it's pulled by this magnetic field. All right, okay. So this is what I want to discuss with you today. Make sure you know whole sequence. From beginning is always power station, and try to remember the figures. Okay, remember figures here, 11 kilovolts at power station, and you need to step it up before you transmit. So it all usually goes to 275, right? Not up. I have not heard up to 500 kilovolts. Right? It's about 275 kilovolts. Some of it on 3 kilo. Okay, so before you transmit, the reason why you want to increase is you want to minimize heat. You minimize power loss when it's transmitted over long distance. Because if you start with something less, when you reach the place, it's even going to be even less. But if you start with something high, the value is already high. Before you start to transmit, the thing is already high voltage. Then when you reach it there, of course, you will lose some along the way, but you will still have quite a lot. Your voltage is still quite high, even when you reach that place. Okay, rather than you start with something small, when you reach there, it's even less, much less. So when you reach that one, the power, the current that, the voltage that reach the area, right? You will still have quite a lot of high voltage, and then you step it down. You step it down for the consumption of the consumers. So here when you reach the place here, you have to step down all the way depending on the needs. So whether it's a heavy machinery, a heavy industry area or light industry area, or even offices or hospitals or houses. So you can remember the voltage: 33 kilovolts, 11 kilovolts, 415 volts, and 240 volts. Okay, so that is the whole system I want to do to you today. All right, so for this class, right, 777, afterwards you go into the Google Meet, we will do questions, all right? And then next lesson, we'll talk about the wiring system in our houses. Okay, that's quite interesting also. All right, okay, so at the moment, I think no questions are. So I will see you afterwards. All right, okay. So those who are joining my class, thank you very much for joining. Okay, I'll see you in my next lesson. Okay, bye-bye.